Hello everyone, and welcome to this training course on the Internet of Things for hydrologic measurements. This training has been organized by myself, Douglas Nyole, together with my colleagues Selroy James Chawanda, Professor Yan Dales, and Dr. Veronica Minaya. This training course has been organized into 10 modules. In Module 1, we will introduce you to the Internet of Things. Next, in Module 2, we will cover the basic components of an IoT system. We will then introduce you to Python or MicroPython in Module 3. This is a language to be used to control these IoT systems. In Module 4, we will introduce you into the IoT processing unit. Next, in Module 5, we will then build up the first basic IoT system. We will then move ahead and build an improved IoT system with more sensors in Module 6. Module 7 then covers two very important concepts in an IoT system: the keeping time concept and the deep sleep concept. In Module 8, we will build our own LoRa gateway system for data transmission. In Module 9, we will then cover IoT data transmission, storage, visualization, and download. In Module 10, you will then work as an individual or in groups to build your own IoT project using the skills you will have gained from Module 1 through to Module 9. So let's go ahead and start with Module 1. What is an IoT system? We will define this by covering the different letters that make up an IoT, which is I and the T. The O stands for off, so we don't have to define that one. So what does the I stand for? As I had mentioned, I stands for the Internet. And what is the Internet? The Internet can simply be defined as a network of networks. Or in other words, the Internet is a vast or global network that connects computers all over the world. So, through the Internet, people can share information, communicate by email, for example, from anywhere in the world using the Internet connection. Next, we will look at the T in IoT. What does the T stand for? The T stands for things. And the things in this case are the devices or objects with intelligence that are able to connect to the Internet. Therefore, what is an IoT once again? This is a platform where intelligent devices or objects are able to connect to the Internet and be able to communicate or interact, collaborate, and exchange data with each other. Therefore, when all these devices are connected to the Internet, it forms what we can call a network of devices. Others may say Internet of everything, as long as these devices have the intelligence to connect to the Internet. Then, why do we need an IoT system? IoT systems have been able to reduce human interventions in machines or devices because they've been able to help with automating and simplifying many tasks that would have otherwise been done by human beings. So imagine a world in which every device in your home, workplace, car and city are connected. Picture that. In the context of environmental monitoring, or in this case, hydrologic measurement, IoT systems have been built, configured, and even deployed to take measurements, store the data, and share the data in real time or near real time from wherever they are. And we're able to access this data from wherever we are. Imagine also a world in which you can take measurements from almost anywhere in the globe without having even to physically go to these places to take the measurements. Then this data is able to be sent to you wherever you are, and you're able to access it through your device, whether it's a mobile phone, a smartphone, or your computer or a tablet. Even better, Imagine a system that has the ability to even warn you whenever there is a problem so that you can take the right action early enough and save the situation. In the next slides, we're going to look at the applications of IoT, and the first example would be IoT for smart homes. At present, there are many applications of IoT in our homes. For example, smart TVs. We are all aware that the modern television sets are able to connect to the internet with numerous smart features, for example, voice or gesture recognition. Smart lightings have also been installed in our homes today that are able to adjust the lighting, self-regulate based on the daylight availability. We also have smart thermostats in our home that are able to schedule, monitor, and remotely control the temperatures in our homes. We also have smart locks that you're able to grant remote access to whoever wants to go and view your house, if it's a family member or a potential tenant. IoT has also been applied for smart security systems. For example, cameras that are connected to the internet and you're able to monitor your home from wherever you are. Therefore, the list of IoT applications in our home is long. The next example are the IoT wearables, what we would call the smartwatches. Most of the smartwatches connect to your phone, and through your phone they are able to connect to the internet. There are few examples though of smartwatches that are able to connect to the internet directly. Therefore, the IoT wearables or the smartwatches can be used as GPS tracking systems. They can also be used as audio systems, as cameras, and for activity trackers, which are able to connect to the internet and store all this information, and you can access them from wherever you are. The next example are IoT for smart cities. Many modern cities are already embracing IoT. In these cities, IoT has been used for traffic management, smart grids, that is in terms of electricity connected to buildings, water management through metering systems, waste management, urban security through the cameras that are connected all around the city, pollution control through sensors that are able to measure the pollution levels, for example, air quality. The list of applications of IoT for smart city is long, as you will see in this image. IoT has also been applied in agriculture, and they've been able to support with doing the right activity in the right farm location at the right time. For example, precision farming or precision agriculture. Therefore, with IoT, you're able to know exactly where you need to do any activity within the field. Agricultural drones have also been applied so that you're able to monitor the performance of your fields. In irrigation, we also have what we call the smart irrigation system, where IoT has been applied to control the amount and the timing of irrigation. IoT systems have also been used in greenhouses to be able to control the environment inside a greenhouse, for example, the temperature, the humidity. For soil monitoring, for example, the soil water content, IoT systems have also been used for that purposes, and this is closely linked to smart irrigation. So the list of applications of IoT in agriculture is long and continues to grow day after day. The next example is IoT for environmental monitoring. IoT systems have been used, for example, to monitor air quality, water quantity and quality, rainfall or precipitation, temperatures, solar radiation, wind speeds and wind direction, and humidity. For example, what you see in the image is an example of an automatic weather station that is connected to the internet, and you're able to view measurements at real time or near real time, like what you see also in the image. I invite you to have a look at the Internet of Water Flanders. That is an organization that is applying IoT systems to monitor the water quality in Flanders, Belgium. In this slide, we look at how IoT is being applied in different areas. At the top of the list are the smart homes. The smart homes have benefited a lot from IoT system, followed by wearables. The third one are the smart cities, and the list continues. At the bottom, we have smart farming. Not in the list also is IoT application for environmental monitoring or hydrologic measurements. What is then the future of IoT? According to a study by Accenture, the number of connected devices is expected to rise beyond 40 billion by the year 2024. And according to Ericsson, advances to the internet will be accelerated through increased network agility, integrated artificial intelligence, and the capacity to deploy, automate, orchestrate, and secure diverse use cases at hyperscales. Thank you.